Hello everyone. In this lecture we shall discuss the solution of game for given m×2 type payoff matrix. Here we use the graphical method. In the previous lecture we have seen the case of 2×m. Right. In the previous lecture what we have discussed? We have discussed the case of 2×n. Right. Here you should refer to the previous lecture before going through this lecture. Here we consider a m×2 matrix of this following form. Right, a11, a12, a21, a22, like this, am1 and am2. This is a m×n matrix. Okay, so let us now discuss the working rule. Prior to that, let me to introduce myself. Professor Susanta Kumar Paikray, currently working as a professor in the Department of Mathematics, Veer Surendra University of Technology, Burla, Odisha, India. Okay, so now coming to the working rule. In step 1, what we will do? In step 1, we'll consider two vertical lines. As I have told you, consider two vertical lines. Vertical lines at a unit distance apart. Okay, after taking this two vertical lines, we have our step 2. Means here we take two parallel lines here at a unit distance apart, and let it be my B1, let it be my B2, or if I write B2 it's also fine, if I write B1 also fine. I am taking this and I mark these points here, a11 point, a12 point, so on, maybe negative value may be there, I may represent it. Similarly, suppose a21, a22, a12, this is a11, this is a21, likewise a12, a22, likewise I will mark all this, a32, so on I will mark. Then so consider two vertical lines at a unit distance apart and mark your AI is there. So here these two parallel lines, this represent, we just write one line representing B1 and B2. Right. Then in step 2, here join AM1. Right, AM1 on B1 line with AM2 on B2 line as given, which represents your AIs, is not it? Which represents your AIs. Now if you recall here, what is the objective of B? The objective of B is to first you find the column maxima, then you find the minimum of the column maxima. Okay, that means minimize the maximum profit. So for maximization we have the upper envelope and this is the lower point, so we have to find the lowest point. Okay, lowest point of the upper envelope. What does it mean? Means we join here A1, we join here A2, right? We join A3 and so on we join. Then bounded by all the lines, the upper envelope, right? The upper envelope. Let this is the upper envelope. It's common to all this. Okay, this is the upper envelope. And we find the lowest point, upper envelope and this lowest point, right? This point is my lowest point, right? Lowest point, or that means my minimax point. Okay, this is my minimax point here, the minimax point here. This point is my minimax point. Okay, so this is my intention. Then my step 3, I find the lowest point of the upper envelope. Okay, and reduce it to a 2x2 game. Okay, 2x2 game, and use the usual mixed strategy technique to solve the game. Okay, so let me to solve one example, then your idea will clear. Now coming to the solution of the game, you are given a game. This is a game of payoff matrix of order 6x2. Okay, and our intention is to reduce it to 2x2, right? 2x2. So we'll see whether there is a saddle point. So coming to the solution, there is no saddle point. You should check it. Saddle point. However, it can be dominated, right? However, you see your A1, right? A1 is superior to, A2 is superior to A1, right? Also it is superior to your A5. You see, also it is superior to your A6, right? However, your row 2, right? Row 2 is superior to, greater than, is equal to row 1, row 5 and row 6. So row 1, row 5 and row 6 are dominated by a row 2. So we just omit it. We just delete this, and we just delete this. Now the reduced matrix is here B1, B2, and it is having 1, 3, 5, minus 1, 6, 3, 5, minus 1, 6, and 4, 1. Okay, 4, 1. It is here A3, 4, A2, 3, 4, A2, A3, A4. Where further domination is not possible, right? So we have to see the graphical method now. If from the beginning it will ask that use graphical method, we will not dominate, we will directly solve it. Okay, but here just it is asked that solve this. So we are first applying the dominant rule here. So now let us draw the graph. This is now we are reduced to 3x2. Now we consider here we use graphical method as follows. Consider two vertical lines representing B1 and B2 at a unit distance apart, as follows. Right, you draw the lines. So there is a negative -1. So you draw the lines like this. So this is my B1 say, and this is my B2 say. In my B1 I have to write -1, 3 and 4. So let it be my -1, this is my 0, this is my 0, this is the same distance 1, 2, 3. I need 3 and 4. This is my 3 and I take 4 here. On your B2 we have 1 5 and 6. In B2 here it is here 1 and it is here 5 and it is here 6. Okay, so you draw the lines. You draw A2, A3 and A4 here. So now you draw the lines. A2 is the intersection of 3 and 5. So we join 3 and 5 here. We join 3 and 5 here. 3 and 5 here. This is my A2. Then we join -1 and 6. This is my A3. We join -1 and 6 here. Right? We join -1 and 6. We join -1 and 6. And it is my A2. It is my A3 and A4 is my 4, 1. A3. A4 is my 4 and 1. So I write join 4 and 1 here. Okay, 4 and 1 here. 4 and 1 here. And this is my A4. This is my A4. Now we see the upper envelope. Now we see the upper envelope because the objective of V is the upper envelope minimum point. So the upper envelope. So the upper is this. This is the upper. The upper is this. The upper is this. So common to all. So this is my upper envelope. Okay. So this is my common to all is my upper envelope. And what is the lowest point? And this point is the lowest point, right? This is the lowest point. Lowest point of the upper envelope. Upper envelope. Right? Upper envelope. So this point is the intersection point of A2 and A4. Right? This point is the intersection point of A2 and A4. So this is my A2 and A4. A2, A4 point. Right? A2, A4 point. A2, A4 point is this point. So now this is my upper envelope. Upper envelope. Right? So here A2, A3 will be there. And here A1 will be. Here A1 will be. This is A2 and A4. Now this A3 will be dominated. So this line will be dominated. A3 will be dominated. Clearly from the graph. Okay. Clearly from the graph. Clearly from the graph. The lowest point means my minimax point. That means my minimax point. Minimax point. Okay. Clearly from the graph, the lowest point of the upper envelope. Upper envelope. The lowest point of the upper envelope, that is this point means what? This point means my minimax point. Okay, that is minimax point. This minimax point is the intersection of here A2 and A4. A2 and A4. Consequently, here A1 is A2, A4. A3 is dominated. Consequently, A3 is dominated. And the reduced matrix is given by here B1, B2 is silent here, and here A2, A4. Okay, this is a 2 cross 2 matrix. Now A3 is dominated, right? A3 is dominated. The reduced matrix is 3, 5, 4, 1. 3, 5, 4, 1. Let it be of the form A1, 1, A1, 2, A2, 1, A2, 2. Now we apply the mixed strategy case as usual. Let the mixed strategy for A, and B denoted by SA and SB respectively, given as follows. So for your SB, for your SA, we have earlier A1, A2, A3, A4, A5, A6. Okay. So the things which are available now is A2 is my P1 and A4 is my P2. Remaining are 0 because these are all dominated. Right. And my SB is my B1, B2 and it is Q1, Q2. Okay. Such that P1 plus P2 is equal to 1 and Q1 plus Q2 is equal to 1. Now let my lambda is equal to here this plus this, A11 plus A22 minus A12 plus A21, just you add them. So this is 3 plus 4 minus 4 plus 5. This is 3 plus 1 minus 4 plus 5. So this is equal to 4 minus 9 is here minus 5. Then coming to your value of the game, here V is equal to, right, V is equal to here A11 into A22 minus A12 into A21 divided by your lambda. So this is equal to your 3 into 1 minus 4 into 5 divided by minus 5 is equal to 3 minus 20 by minus 5. So this is equal to your 17 by 5. Now coming to your next, my P1 is equal to my 822 minus 821. 822 minus 821 divided by my lambda. So 822 minus 821 is my 1 minus 4 by minus 5. 1 minus 4 by minus 5 is your 3 by 5. So this implies P2 is equal to 1 minus P1 is 1 minus 3 by 5 is 2 by 5. And here Q1 is equal to, Q1 will be here A22 minus A1 to 1 minus 5. A22 minus A12 by lambda. This is 1 minus 5 by minus 5 is here 4 by 5. So this implies here Q2 is equal to 1 minus Q1 is equal to 1 minus 4 by 5 is 1 by 5. Okay. Hence the optimal strategy for A and B are SA is equal to A1, A2, A3, A4, A5, A6, and here A2 is here 3 by 5 and here A4 is here 2 by 5, remaining are 0, and SB is equal to B1, B2, Q1 is 4 by 5, Q2 is 1 by 5 respectively. Having the value of the game V is equal to 17 by 5. So this is your answer. Okay. Now coming to the summary of the lecture. In case of your M.Sc matrix, we take two vertical lines representing B1 and B2 and draw your AIs, and you find the upper envelope and the lowest point of the upper envelope, what is known as your minimax point. Okay, and that minimax point is the intersection of two lines, and we consider these two lines and you remove the others and accordingly apply the mixed strategy formula here. Okay, so now the thing is that if it is not solvable by these techniques, then we will have to solve by your linear programming technique. So in our upcoming lecture, we should discuss the LPP, linear programming technique. Okay, linear programming technique, and we use here the simplex method. This method will be lengthy, right? This is the usual method. I will just tell you how to convert into a LPP, then we can use the simplex method. Okay, so now before I conclude, just my one appeal to all of you: if you feel that this lecture is helpful to you and interesting to you, please like and subscribe to this channel, which will boost my motivation to upload the subsequent video for your benefits. Okay, so let us close this lecture here. Thank you all. Have a nice day.